Hi, going to make a brief pen cast on proving that the hoop stress is twice the axial stress. So for example, if we take a tin can, we're going to make the assumption that this is a thin wall section. That's important. So if we fill a can full of pressure, we will see that the can will feel in that direction. So we want to prove that the hoop stress is equal to twice the axial stress. So two things we need to know is pressure is equal to force over area, and two, stress is equal to force over area. So if we equate those, we can say that force is equal to pressure times area, which is equal to stress times area. So we see that and that, we get an equation. So if we take the stress element on a axial, and if you can imagine that this is an element through this section, and here we have the area. So let us call this dx. Let us call that 2 times the radius, and let's call that the t. And if you imagine, we have pressure in here emanating equally all around. So we can come up with the conclusion that the stress is equal to, as above, is equal to force over the area, and the area is 2 times t times dx. And can we see the restraining? And that is equal to the combination of that area. The pressure is equal to the force over the area, which is 2r dx, and that area is this total surface area. So if we put those equations together, stress hoop, we say the stress hoop and if we equate this into force, stress hoop 2t dx is equal to the pressure times 2r dx. We then get the stress hoop is equal to p 2r dx all over 2t dx. Simple cancellations, and that equates to pr all over t. If I do the same calculation for the axial stress axial, and quick diagram of the axial stress we're talking about, we've got the total area and we've got the axial resisting force. So we say stress axial times 2 pi rt is equal to the pressure pi r squared, and that side is equal to the hash, and the side is equal to the green area. If we do the same calculation, we end up with the stress axial is equal to, excuse me, is equal to P pi r squared over 2 pi r t. Do some cancelling out here. We get, and that equates to pi r over 2t. And that's the stress axial. And if you compare that up there to the stress hoop, we get that the stress hoop is equal to 2 stress A, because from up above we see P r T is equal to P r over 2t.